Let's now take a look at this magic trick involving the base 10 arithmetic. Let's take any three-digit number where the first and last digits differ by 2 or more, reverse, and then subtract. So, for example, 782 minus 287 is 495. Let's reverse and then add, let's prove that we always end up with 1089, no matter what. So let's let n be equal to 100 times A plus 10 times B plus C. And without loss of generality, let's take A to be bigger than C. The hundreds digit is bigger than the ones digit because we're going to be reversing. So the reverse, so n sub r reversed, would be equal to 100 times C plus 10b plus a. So when we subtract, we get n minus n sub r will be equal to, subtracting, we get 100 times a minus c plus c minus a. So that is the answer that we get. Now notice that what we have written down here on the screen is not in base 10. A minus c is going to be a positive number, but c minus a is a negative number, so that's not in base 10 form yet. So the way to make this in base 10 form is as follows. Let's write this as 100 times a minus c minus 1. Then I have plus 100 plus c minus a, and that's equal to 100 times a minus c minus 1 plus 90 plus 10 plus c minus a. This is now in base 10 form. For example, for the problem that we had over here, we had just numerically, here a was equal to 7 and our c was equal to 2. So according to my formula here, we would have 100 times a minus c minus 1 plus 90 plus 10 plus 2 minus 7. So that works out to be 100 times 4 plus 90 plus 5, 495. And so the last expression that we have here is in base 10 form. So that's our numerical example. So that is our difference. So let's call that difference D. Now let's reverse the difference. When I reverse the difference, I would have this part, the ones digit now becomes the hundreds digit. So 100 times 10 plus c minus a. The tens digit stays the same, 90. And the ones digit is now a minus c minus 1. And so if I add these two things together, d plus the reverse of d, on the first part here I have 100 times this times 100 times that. If I add them, everything cancels except for 10 minus 1. So I'll end up with 100 times 9. Just adding these two expressions. Then I have 90 plus 90, which makes 180. And then on the units part, a minus c cancels c minus a, leaving me 10 minus 1, which is 9. And so that ends up with 900 plus 180 plus 9, which makes 1089. And so that is our proof that we always end up with 1089, and this comes directly from our base 10 properties.